Hi, this is Maxime. I'm going to present you my project on detecting tumor cells on a medical image. This is what our image looks like, and there are tumor cells. They're located here. If we superpose them, we get this. So the goal is to detect that tumors are located in these spots and that all the rest is healthy. This is going to be my training set, which is what I'm going to train my model on. We'll also have a validation image that will look like this, and where the tumors are located there. As you can see, there's much more tumor on this validation slide. First, a baseline model, just to get the flow working. At the lowest definition, labeling each image based on whether the center pixel has a tumor or not. And so that way we're generating lots of images from our main image, and I mean this is the validation. Yes, from there, and we're generating a bunch of 40 times 40 images from this image, and we're going to classify all of them. To deal with the big imbalance between tumor and healthy cells, I'm just resampling both of the classes to get an imbalanced set. So this is what one of these images looks like. Here I'm using a preloaded network from VGG16 to increase learning speed. This is the confusion matrix I get. As you can see, there is a really high specificity, and sensitivity is good too. 70% for sensitivity, 86% for specificity. However, as you can see, it basically tells us that all the cells are have a tumor. This is because actually it's the metrics are being boosted by the fact that we don't predict tumor outside of the cell. So this is why we need to focus only on tissue cells. So I'm only selecting the tissue cells. If I'm doing the same again, we can see that we have a relatively decent confusion matrix for a first try with specificity. However, that is really average. So this is the heat map, the prediction heat map that we get. We have to use data augmentation though, because as you can see, tumor cells that are on this side, like on to the right or to the bottom, might be detected, but those that are on top or to the left aren't, because in our training set, the only border tumors are on the right and bottom side, not on top and to the left. So I'm introducing flips and changing also brightness, the brightness parameter. And this is what I get. So 71% sensitivity, 60% specificity. So it increased both metrics, which is really cool. This is what we get. So areas like this now gets recognized as tumor versus before. Now I'm going to zoom in because this was at the lowest definition. And this is what we get. So it's getting a little sparser, as you can see. The confusion matrix is here. So there is 61% sensitivity and 74% specificity. So specificity is increasing as we're zooming in, and this is actually even more obvious in the next step. I'm zooming in once more, so to the next level, and wow, we get a specificity that is super high. But this comes at the cost of the fact we don't really recognize tumor cells very well anymore. So to deal with this, I tried just changing my class weights by penalizing wrong predictions on tumor cells more than 3 times more than on healthy cells, for instance. And this really improves our predictions a lot. However, sensitivity is still only at 54%. So I decided to zoom in to the maximum level, so the maximum definition. And this is what we get, a really amazing confusion matrix on the validation sample that has basically a very good prediction both on the healthy side and the tumor side. So 94% sensitivity and 91% specificity. And this is what we get on the validation sample. Wow, it really identifies all the tumor cells really correctly. Even this little bit here gets classified correctly. Basically, the only 2 issues that we have left here are this, that is wrongly labeled as a tumor, and this part here that is wrongly labeled as tumor. Here and here. Other than that, it's really satisfactory, but we need to make sure that this is not an overfit, so I'm going to load another slide just for testing purpose. This is what our testing slide looked like. The tumors are located here. And this is the prediction that we have on this test set. So 87% sensitivity and 95% specificity. This is our prediction, and this is where the tumor cells actually were in black. So as you can see, so the main tumors are identified, but also these little things here get labeled rightly. There is a little bit of noise in our prediction as well, all these red points here and there. But overall, it works really well, and so we were able to achieve an 87% sensitivity and 95% specificity a model on the test set for this project. Thank you for watching.